Welcome to series of database management system video lectures. Today we will be discussing about Unit 3, Topic 6, that is serializability in database management system. To understand serializability, let us recap a few technical terms which we have already discussed as part of the previous videos. What do you mean by transaction? Transaction is a basic unit of processing, right? And the next one is schedule. The schedule is nothing but a series of steps or series of operations which are going to be performed at a given point of time. And the third one is serializable. We will see what do we mean by a serializable schedule, because schedule is termed as serializable or not serializable. Before that, let us look at two schedules. This is schedule 1 named as S1 and this is schedule named as S2. Now let us look at a schedule S1. Assume that A and B, the data members which have the initial amount as 1000. Now look at the series of operations which are taken by transaction table. Before we get into it, let us look at the schedule here. Is this schedule a parallel schedule or a serial schedule? That we need to identify first. A schedule is going to be called as a serial if the set of instructions as part of T1 transactions are done completely and only then T2 transaction will come into the picture. Now, by looking at this, some part of T1. Now, let us look at the set of instructions as part of T1 transaction. Some part of T1 transaction will start its execution and then it stops. And then the next part of the first part of T2 transaction gets executed, it stops, and then the second part of T1 transaction starts the execution. So which indicates that both T1 and T2 transactions are not serial. Serial indicates that the complete set of transactions of T1 gets done and later complete set of transactions T2 are done. So this schedule can be called that it is in parallel or concurrent schedule. So in this concurrent schedule, the data members, in terms of accessing to the data members are going to be either shared data members or not. Now look at here, T1 first transaction, second and 3 operations are done. During that point of time, there were no operations which are done by T2 transaction. And then at transaction operation 1, 2, 3, 4, 5, while performing these 5 operations from transaction T2, there were no work done by T1. And later 4, 5, 6 transaction operations of T1 is being done. At this point of time, there were no transactions that are done by T2. This indicates that this shared data, the data members which are being accessed here, will be not modifiable. Okay. So now the data members A and B values which are being accessible by T1 transaction and T2 transactions will be in shared manner. Okay. So now when T1 is acting upon this data members, T2 is not involving. When T2 is acting upon the data members, T1 is not involved. So by this, we can say that we are preserving the data values. Okay. When we are able to preserve the data values, then there will not be any inconsistency of the database. So we are achieving consistent data which is being maintained across the transactions with respect to schedule S1. Right. So when we deal with the serial transactions, lot of CPU time gets wasted and then the throughput of the system will be reduced to a greater value. So in order to overcome with it, we wanted to utilize the resources in an efficient manner. So that's how improving the throughput of the system, we define the schedules in concurrent manner so that simultaneously multiple number of transactions are going to be executed. So that's how S1 is a concurrent schedule, and look at S2. S2 is also a concurrent schedule wherein multiple transactions are taking place at the same point of time, but then not exactly or not simultaneously executing upon it. So this will not conflict to any data members. So which means that when T1 is acting upon a variable, T2 is not involving. So there will not be any conflict or no issue of accessing multiple transactions to the data member, which will definitely lead to inconsistency state of the database. That is not happening here. Okay. So now look at the schedule S2. Now let us analyze schedule S1 here. We are reading value of A, that is 1000, you'll get 1000, and you are deducting 100 from it. So it becomes 900, and you are updating this into the database. So now no more this 1000 will be reflected as part of this. So it will be 900 in the memory. Now look at the next one. As soon as we are done with the T1 transaction first part, the processor will perform T1 transactions. And then immediately after doing this, it has to start up with the T2 transaction. So now there will be a context switching that will take place so that we need to access to the T2 transactions, right? So this is what called as switching in between multiple number of contexts, which helps the efficient utilization of the CPU time, right? So in order to utilize the resources in an efficient manner, we need to perform this context switching. While doing this context switching, if we are able to preserve the values in a correct manner without having any conflicts, then we will be achieving the database management system to be in consistent state and integrating all the set of policies. So that is what our main motto of doing that. Now the context switching has been happened. Now T2 transaction has started. Now at this point of time, when T1 and T2 transactions have to start its execution, we need to even check that whether it is preemptive and non-preemptive. Preemptive can happen with concurrent executions. Non-preemptive happens with a serial execution. So in serial execution, if T1 transaction has started, let all the instructions of T1 gets completed, and only then T2 transaction can be started. Let all the transactions of T2 gets done completely. So this is how you will be able to finish multiple transactions. If T2 transaction has arrived with high priority, already this T1 transaction is binded by CPU, right? If CPU is handling T1 transaction, now with a high priority T2 has come into the existence. Now they will make the T2 transaction to wait till the T1 transaction gets completed. This happens only with respect to the serial execution of the transactions. Now look at the parallel concurrent execution. Now in this manner, the processor is already given with a T1 transaction and it has started executing the first operation. And at that point of time, if T2 transaction has arrived with high priority, and if there is a non-preemptive, then it will make T2 to wait and let T1 continue with its operation. And only then, after performing context switching, T2 transaction can be done. If it is preemptive, if the schedule is preemptive, then though you were executing the first statement of T1 transaction with high priority, T2 has arrived with preemptive one, then it should stop doing the ongoing execution of T1 transaction and then it should perform context switching to start the execution of T2 transaction. Now, depending upon the burst time, depending upon the execution time of these transactions, if T2 was given with a less number of transactions, then with the preemptive, let this done first. With this transaction, let T2 gets done completely, and only then after performing context switching, T1 transaction will resume wherefrom it has been stopped earlier, right? So in preemptive, if any high priority tasks have come, then CPU needs to perform context switching, and only then the newly arrived operation is being done. If it is non-preemptive schedule, irrespective of the high priority tasks have arrived, then let the ongoing application or the ongoing transaction gets done completely. And after context switching, which is done by operating system, then CPU will be able to handle, the processor will be able to run the second transaction. This is very important to be read there. Now, look at here, this is schedule S1 and this is schedule S2. Now let us take that A has 1000 and B has 1000. Now let us go through the schedule S1. We are reading, so it gets 1000 here. We are deducting, it gets 900, and then you are modifying in the database, so it is going to be changed to 900 now. Now, to start a T2 transaction, it does the context switching, and then it executes from here. Now you are reading A value, which is there as 900, and then you are creating a temporary variable, and you are calculating the 10% of it, which becomes 90. So temp has 90 here, and now we need to read the value of C. Let us say that C has 500, so you'll get 500 here. Now C value is incremented by adding the temp value. That becomes 500 plus 90, so that is 590. So now we are creating C value, you are modifying the value to be 590. And then context switching happens, then T1 transaction gets done here. You are reading B value, B has 1000, and it is incremented to 1100, and you are updating. Now B no more has 1000, it will have 1100 now. This schedule is fine. There are no conflicts that have been happened during the execution of concurrent transactions T1 and T2. Then we can say that schedule S1 is a safe schedule or non-conflicting schedule. Now let us look at schedule 2. Now we have T1 and T2 transactions, which is concurrent transaction execution, which is happening. We are reading A. Now let us get back to original values of A and B and C. A was 1000, so you'll be taking with 1000. And then A value has been modified, so it becomes 9. Now, to start a T2 transaction, because as we don't find any other set of instructions in T1, we need to perform context switching and start a T2 transaction. Now here you are attempting to read A value. Now, with respect to previous one, A was earlier 1000. It has been deducted to 900 now. This deduction was done, but in fact, it was not updated. In fact, it is not updated in the database. So it remains to be 1000 only. From the perspective of T2, it will have 1000 only. Because T1 transaction has not written any operation to update that. So it will take this as 1000 only. And then you are calculating 10% of A value, that will be 10. You are reading C, C will be 500. You are adding or incrementing C value with the temp value. So it becomes 510, and you are updating C value, that is 510. So B remains 1000 only, C remains 510, right? As soon as you are done with the T2 transaction, again context switching happens, and then we'll get back to T1 transaction. Now we are updating A1. Right now, what do we have in A in the memory? What do we have in A value? With respect to T1, it should be 9000, right? So it is treating that there should be 9000. But when you have access to the content of this, it remains to be 1000. So now it remains to be. So here, as soon as you have performed any modification to the data items, you must and should immediately update to the database. If the updations are not made to the database, then which value should be considered, whether 1000 or 900 should be it will create a conflict now. So from that context, we can say that schedule S2 gives us inconsistent values because because it has not updated the value. That's the reason you'll get inconsistent value, which arises to conflict of variable A. So that's the reason we can call that S2 schedule is a conflicting schedule, whereas S1 is conflict safe schedule. There are no conflicts that happens with respect to the data members, whereas this does. So we need to look at each and every schedule and we need to trace out how the operations are going on. Accordingly, if any data members are undergoing into any conflicts, how do we resolve it, right? So in order to convert this schedule, this S2 schedule to be non-conflicting schedule, then we need to serialize the schedule. Now, let us come back. What do you mean by a serializable schedule? A schedule is going to be called as serializable schedule if it does not have any conflicts with respect to the data members. So convert the schedule into serializable such that there will not be any conflicts that arises. So in that case, we have for every schedule, we will have read operation, write operation, commit operation, and then rollback operations. So we have only these 4 operations that gets performed with respect to any transaction. Now, this can be resolved. This conflict can be resolved when we are dealing with a different set of operations. Now, when we are going with, we need to follow a few points in order to resolve this conflict. The first one is when both the transactions T1 and T2 are accessing the data member A for read operation, then there will not be any problem. So it will be non-conflict. Okay. Now, when T1 transaction is reading and T2 transaction is modifying the value of A, then it will be a conflict. What you are reading by T1 transaction, you'll get old value. What T2 is doing, it is updating the value. So this new value will never be read by T1 transaction. So this will be a conflicting operation. The first one is non-conflicting operation. The second one is conflicting operation. Now let us reverse this. If T1 is performing write operation upon A variable and T2 will attempt to do read operation upon A variable. Even now, again we come across with write and read operations. Again, it will be conflicting operation. Now, the third combination is both are performing write operations. Both are performing write operations. So now in this context also, it will be conflicting because let T1 transaction update the value of A and only after that allow T2 to act upon variable A to update the value. So what the value which you have updated by T1 will not be taken by T2. So though it seems to be non-conflicting, but in fact, if both are acting at the same timestamp, then it will be a conflicting operation. Okay. So now when we do not allow T1 and T2 simultaneously together to act upon A, then it will be non-conflicting. If both are allowed to be accessible simultaneously, then it will be conflicting operation. So we need to focus to bring the schedule into a serializable schedule. Identify what are the conflict operations. Read will be non-conflict. Read, write, read will be conflicting operations, and write. So we need to give focus upon these combination of operations. Whenever we deal with this combination of operations, we need to handle properly such that it should not fall into conflict schedule. Right? Now, let us deal with the same one. When we come across with this read and write operations, conflicting operations, we need to interchange the operations of T1 to one step back so that T2 can start next. So identify that operations from T1 and T2, and then we need to swap that. Let us take one more example to understand this better. Now let us take another example to understand better about how do we convert a given schedule into conflict schedule or non-conflicting schedule. Now let us say that this is schedule 3. Now look at transaction 1 in schedule 3 and transaction 2. The first statement in transaction 1 is you are reading the value of A. The second one, at that point of time, there were no transactions, there are no operations done by T2. And you are modifying the value of A. There are no operations done by T2. These two will take place. Now, context switch happens here. Now T2 transaction starts its execution. Now you are reading the value of A and then you are updating the value of A. Fine. Now you need to look at the next consequent set of operations in both the transactions. You are dealing with A data member and the consecutive transactions in T1, operations in T1 is you are reading. Now we need to look at the consecutive set of operations which are done by T1 and then T2 transactions. Now you are looking at data member A, you are reading and then writing operations, and then read and write operations which are acted upon B, not upon E. So this series of operations can be swapped. Okay, so what we can do is that put the next set of transactions in T1 to up and bring down the set of operations to T2 so that your new schedule will look like this. The first two statements of T1 and then the second two statements of T1 are done together, and then T2 transactions, because these two are non-conflicting operations. Non-conflicting operations because both are acting upon two different data members. T1 is acting upon A, T2 is acting upon B. So both are not conflicting here. So that's the reason identify that sort of non-conflicting operations, and then you can swap with respect to the timestamp so that the new form schedule will be like this. Let all the operations are T1 done first, and then later all the operations of T2 are done first, so that no more conflicts will happen and your data will be in consistent manner by integrating this schedule, by integrating a serial schedule. So now we have converted this concurrent schedule into a serial schedule. Now this schedule is also called as a conflict equivalent schedule, because when there are conflicts that happens, and though there are conflicts which are happening with respect to the operations but upon different data members, never your system will be in unsafe zone. Okay, then we can call it as conflict equivalent. Though you yield the values while doing in this manner or doing in this manner, there will not be any changes with respect to the values of the data members. Here also the resultant values remain same, and here also the resultant values will be same after executing both the schedules. Right? Now look at the third schedule. Now here we have, let us say that this is schedule 5. Schedule 5 has T3 and then T4 transactions. Now, T3 transaction is performing read operation upon Q data member. Okay, now, and then we need to perform write operation upon Q data member. So the data member is same. So far, T1 was acting upon it, T3 is acting upon it, and T4 should start execution upon this. So these to read and write on both data members is called as conflicting operations. These two are termed as conflicting operations here. So now, we need to swap the operations in order to resolve that. Now look at the next one. Let the context switching takes place and T4 transaction gets started, and you are performing write operation upon Q data member. Now let us look at the consecutive set of operations in T3. So again, we encounter write and write operations upon Q data member. So even this becomes the conflicting operations. Now both are write that too upon same data member, then it can be treated as conflicting operation. So now I cannot modify, I cannot convert this schedule into conflict equivalent or a serial schedule. So one thing that we can do here is that completely let T3 be done completely like this, and then let T4 start after finishing this, so that you'll be acting upon right. Okay, so now in this manner you can put the schedule, you can reframe the schedule into a serial schedule, but you cannot achieve it to a concurrent schedule, right? So this is all about how a transaction can be created, what a schedule is, how can you convert the given schedule into a serializable schedule, and how can we identify the schedule is a conflicted schedule. Now to understand this better, we need to get into the next one, that is we need to test whether it is in serializable or not. Take any schedule and then test for serializability.